Correct. And awesome, Lynn. Thanks so much. We're so excited to be here. I'm Jennifer Roeder, and I was a kindergarten in the gamut of education, K-6, special education teacher for 6 years, and really focused on inclusive learning environments and having all students engaged with different levels of content that fit their needs. And Myles is super special, all the way here from Scotland, so it's super nice to have this virtual, because otherwise I don't know that he could have been here for this phenomenal summit. And after yesterday, seeing just the amazing content and the stories and the reality of where we are with computer science, one thing I woke up thinking about this morning is we wouldn't be here right now at this moment without computer science. So this is so important to our youth, to all of our students, our children, and I can't thank the Constellations virtual Computer Science Summit is just amazing, and want to thank you guys all for being a part of that. I want Myles to kind of give you guys some background and introduce himself. He's a very unique individual, and thanks for being here, guys.
Hey, Jennifer, thanks so much for that kind introduction. I'm delighted to be here, and as Jennifer mentioned, coming in all the way from Scotland, and it's a real privilege to be able to join you guys in Georgia, at least virtually, during these strange times. But one advantage is the ability to do stuff like this. So thank you very much to the Constellations team and this great platform, Hopin, which is really allowing us to do this presentation, hopefully with a bit of style. I've already got some accent love, so thank you very much to the audience as well. Hopefully can provide something slightly different for all of you. So yeah, I think what I'll do is I'll get started with the presentation, and that will allow me to introduce myself. So let's give this a go and see if this works. Okay, so I'm going to share with you my screen one, and with a bit of luck, hopefully you will all see a presentation. Jennifer, tell me, are you seeing this loud and clear?
Live and clear, it's perfect. Thank you.
Okay, that's awesome. Thank you very much. Well, so as Jennifer's saying, the topic and the important part of this conversation, have no fear, because Marty the Robot is here. I'm hopefully going to bring life with some experiences from Scotland. I represent a company called Robotical. We're an ed tech organization based in the capital of Scotland, a place called Edinburgh. It's somewhere that I would recommend you to visit. It's a great place. But more importantly, it's creating a bit of an ecosystem with some interesting ed tech companies at the moment, and we're one of them. So what do? We bring STEM learning to life. So we partner with schools and teachers to help deliver digital and coding lessons to young people. And we do that by making an educational robot called Marty. Now, I do apologize. I'm getting quite a lot of messages through my screen. Jennifer, I think, can you see that as well, my Slack?
Oh, yes. Coming through.
1 second. Let me see if I can just stop that coming through. I'm going to close that, and hopefully we can present again. And that should be slightly less distracting. Perfect. So yeah, Robotical are the makers of an educational robot called Marty the Robot. Marty was designed by our founder and CEO, Dr. Alexander Enoch, or Sandy, as we like to call him, who was doing a PhD in robotics at the University of Edinburgh. And with Christmas coming up, he wanted to get his niece a present that would reflect the type of work that he was doing.
Myles, can we reshare? I'm sorry to interrupt. Can we reshare your presentation, please? I think it disappeared there for a second.
I do apologize. Let me see if we can try again. And can you see this now?
Got it. Yes. Thank you.
Perfect. That's great. Fantastic. Okay, so as I was saying, our founder, Dr. Sandy Enoch, had Christmas coming up and a bit of a dilemma. His niece was showing some interest in what he was doing, Yet he couldn't get anything on the market that was going to really demonstrate what real robots were all about. You know, he was looking through various options and saw a lot of remote control novelty style toys, which would certainly be fun, but maybe wouldn't provide the learning progression that he felt that she wanted or needed. Or else there are a lot of robots on the market that were kind of tricky to use and maybe a bit academic and not particularly accessible. Certainly didn't have a learning progression that was going to provide the route that she needed to really get under the skin and understand, everything that she needed to in terms of a kind of engineering or robotics pathway. So he thought he would do something about it, and he invented Marty the Robot. And before I go on to speak anything more about the company and a bit of hopefully interesting news about computer science developments in Scotland, I thought it'd be useful to show you a wee video. So Jennifer, I believe that you're able to show this video at this point.
Yes, I'm sharing my screen. And do you have access to my screen?
I can see you.
And I'm trying to get it to play. Do you have access there?
Currently, I can see you still.
Do we have movement there, Myles?
I tell you what, maybe it's on the third button. If you press on that, you should be able to see the third button at the bottom of your screen, Jennifer.
Yes.
If you press on that, fingers crossed, it will then show you.
So on my side, it says share the screen, and my entire screen should be showing. Does that pop up at all?
If you then click on screen 1 and share, hopefully that'll do it. Yes, here we go. That's it. Perfect. And if you then go to your tabs, with a bit of luck, there you go. That's the video. I can see it. And if you just maximize that screen, we should be
wonderful.
Able to see
Thank you.
Fantastic. And hopefully we can hear that as well. Maybe not. It's not super loud, but what I'll do, I can maybe talk a bit over this whilst it's playing, but hopefully the audience can see the screen. If you keep that at maximum, Jennifer, that's perfect. And this just, I can explain a bit about what's going on here. We've got this video was shot at an Edinburgh School's robotics and coding competition. It pitted a number of school children against each other in creating a really fun dance for Marty the Robot, as well as an obstacle course. They had to go and program their robots to get around specific challenges. And so it was a really fun day and event. We had good fun shooting it, a behind the scenes video, etc., which was really good fun. What we learned from the whole experience was that Marty the character really did engage with kids from all sorts of different backgrounds, and it excited them in bringing their STEM learning to life, working collaboratively, thinking about multiple forms of technology, robots, tablets, video, camcorders, music, etc. And they had to bring all of these components together to make their school proud and make their team proud and demonstrate that they had a bit of an entrepreneurial spark and streak, as well as the ability to really work well together to get their robot to perform various functions. So that gives a bit of an overview of what we did. I'm sorry we couldn't bring the sounds to you, but I'm sure we'll have all the YouTube links later on, and we'll be very, very happy to share those with you at the end of the session. But in the meantime, Teresa may be able to help us with the sound. So Teresa, if you do hear this and can help, I'm sure we'd be very grateful if you can help us with the sound for later in the presentation. So that's a bit about Robotical and Marty the Robot specifically, but I'm not just going to speak about Marty today, as much fun as that would be. I also want to tell you a bit about Scotland and our education system. And I also want to be clear that whilst I'm not in the classroom, and I'm certainly no expert when it comes to teaching computer science, I have spoken to a lot of teachers over the last few years since I've been involved in building Robotical, and we've gathered some really interesting feedback from teachers, and I hope to share a bit of that with you today. And of course, the Georgia education system will have differences with the Scottish education system, but the more markets that we're involved in, the more we see that there are similar challenges across different areas, different countries, different states, etc., that computer science teachers have to grapple with. So hopefully this presentation will bring some of those issues that are universal, and you'll find that interesting in itself to follow and understand, and perhaps we can work together to see if we can come up with some interesting solutions. So a bit about Scotland. Marty grew up in Edinburgh, as I said, and over the last decade, Scotland's increased its focus on STEM learning and coding. And we wanted to share our experiences of developing approaches to planning and implementing STEM learning, how lessons in Scotland are structured, and how teachers have developed their skills and confidence in a way that has allowed them to create engaging and interesting learning experiences. So a little about Scotland. With around half the population of Georgia, compulsory schooling starts around 5 years old, but nursery education is available from those who are age 3 for parents who choose it. And Scotland's education system is a bit different to our neighbouring UK countries. So students study a wide range of subjects until their 10th year of compulsory schooling before selecting a range of national certifications at age 16 and 18. And we have limited standardized testing too. We have a national curriculum framework that defines learning benchmarks, but it does not define how the teachers teach, and nor does it define what must be achieved each year. The aim here is that teachers have the flexibility and autonomy to tailor their approach to their school, their children, and their local community. And so, specifically with digital and coding, over the last 10 or so years, the government has introduced a range of strategic documents and guidance in an effort to grow STEM and digital skills in Scotland. This has resulted in children being introduced to digital literacy and computer science concepts from the age of 3. All children continue to receive some kind of digital and CS education through to the age of 15. They can then choose whether to continue by selecting from a range of national qualifications. And so the government here believes that coding and digital skills are key to Scotland's success in the 21st century. And there are a range of national programs aimed at increasing awareness of the future career opportunities that will come from an understanding of tech, coding, and other STEM subjects. Our home city of Edinburgh is currently leading a £600 million investment in creating data science expertise, and this program extends to delivering data science and digital training to teachers and schools. It brings together schools, communities, colleges, and universities to create tech-oriented skills pathways that offer young people a wide range of well-structured training routes into tech jobs. And so the curriculum experiences, there are 2 areas of the curriculum that deliver digital and coding skills. And the aim is to give kids the skills to understand their digital world and know how to behave within it, and be a good citizen. CS is about computational thinking, great for problem solving, planning and organizing, and of course, learning to code. So the first strand, digital literacy, this focuses on building an awareness of the digital world and how to behave in it. Young people are taught to consider legal and ethical issues of being online and to reflect on their own behavior. And here are some examples of what kids are expected to be able to do in primary school. You can see that even from a very young age, kids are expected to learn to work with tech and develop an awareness of it. And when we've looked through the Georgia Standards of Excellence for Computer Science, we can see very similar outcomes required for your learners. So there's a lot of overlap. And the second strand, computer science in primary, again, the learning outcomes focus on understanding computational thinking and learning how to code. And here are some examples of what kids are expected to be able to do in primary school. So from age 3 to 5, this is designing a simple sequence of instructions or algorithm for programmable device to carry out a task, for example, directional instructions such as forwards and backwards, and identifies and sequences the main steps in an everyday task to create instructions, for example, washing hands. From age 5 to 8, makes decisions based on logical thinking, including if, and, or, and not, demonstrates an understanding that computers take information as input, process, and store that information and output the results. And ages 9 to 11 identifies algorithms that include repeated groups of instructions, a fixed number of times and or loops until a condition is met, and explains the meaning of individual instructions, including variables and conditional repetition in a visual programming language. Now, I don't know about you, but sometimes terminology within curriculum documents can be pretty confusing, and it can show a lot of technical words, for example, which can often be a problem for teachers who maybe aren't certainly at primary level. That might not be their main subject, and suddenly they're looking at documents that appear quite technical, and Scotland's certainly no exception to this rule. And so I just wanted to quickly go over, and apologies if you know, all of you are experts in this field. I'm sure you are. But I just wanted to say, you know, for everyone, computer science should be totally accessible. And so some of the words here, like algorithm, is simply a fancy word for a sequence of instructions. We all use algorithms every day. I know I do the same steps every day to make morning coffee, for example. And we've found that even the youngest children can develop this kind of understanding. It helps them develop initial ideas around computational thinking. As they get a bit older, they start to understand logic and conditional statements. Again, these are concepts that as adults we understand, even if we don't quite use the terminology. So a conditional statement is something like, if there's coffee in the machine, hit start, else add ground coffee. So logic statements are a simple way to understand how computers take decisions. They are often combined with conditional statements. For example, if it is raining and I want to walk the dogs, put my rain jacket on. In this example, both it is raining and I want to walk the dogs have to be true for me to put my jacket on. And an and statement means you can put a range of statements together and they all have to be true for the next step to happen. And or allows you to consider a few different ideas. So if day equals Monday or day equals Tuesday, then get up at 7 a.m. Not allows you to exclude things, for example. If not Sunday, get up at 7 a.m. Else, get up at 10 a.m. This saves you writing out 6 days of the week. A loop, as noted in ages 9 to 11, means to repeat something based on a condition. So while there is no bus, wait at the bus stop. And variables is something we can change each time a computer program is run. It could be something as simple as a person's name. Now, again, we believe that having a bit of hardware can bring a lot of this to life, and we'll go into more detail later in the presentation. And a quick note, just to finish off the education system in Scotland. So secondary education, like your high school, the first 3 years continue broad general education. Ages 14 to 16 study 6 to 8 subjects to national certification. and then ages 16 to 18 study 3 to 5 subjects more in depth to national certification. And there are a wide range of computer science certifications available, such as data science, information technology, web design, etc., etc. So that finishes the overview of the education system. However, as I've intimated, very few teachers have received training on coding or digital within their teacher training program. And so there are concerns. How can I teach something I don't know about? Or schools can often have poor Wi-Fi or old computers and a lack of infrastructure to deliver innovative, exciting lessons. How can I teach coding without lots of tech kit? And, you know, this is maybe specific. I'm sure there'll be parts of Georgia that are the same, but in Scotland, we have some communities that are very rural, island communities, for example. And yeah, it can be a challenge where some schools are maybe have more option of having tech compared to others. And so there is a kind of concern among some of the teachers that we speak to about this. And so for us as a tech company, it is great to see, you know, the government's emphasis on digital and computer science. But as you might expect, it's not straightforward to implement some of these strategies and documents. And the increased focus on STEM and coding, while broadly supported by schools and teachers, has raised significant challenges, particularly in primary school. So a couple of the challenges mentioned there, but there are some others. So a lack of understanding of what STEM and digital is and why it might be important. A lack of understanding that can extend to families, learners, and teachers in primary who are very focused on literacy and numeracy. Other challenges such as poor gender balance, for example. A big thing in Scotland is trying to raise the amount of girls and women going into tech. A lack of training for teachers, and a lack of specialist teachers of computer science or STEM subjects, where some kids are being bused to another school to get their computer science lessons. But there are solutions, of course. We point to collaboration. So kindergartens and elementary school can be strongly encouraged to work together to share how they approach STEM learning, both as staff and for their learners. They are encouraged to use external organizations, often third sector, to offer different ways of learning, like games or coding challenges. Raise awareness through national events, Maths Week event to raise the profile of numeracy and maths and promote the value, relevance, and joy of the subject. Key role models, so providing female role models, for example, in different STEM subjects and careers. Dedicated funding for STEM professional learning. Listen to kids as well. So Young STEM Leaders Award to promote young people to inspire each other to get involved with STEM. And science centres play a key role. Festivals such as the Edinburgh Festival are working with the community learning and development sector to expand their reach into deprived communities. And there's also 2 million funding offered to increase training for STEM teachers, and that is a key component of the strategy. So what have we learned in trying to increase STEM and coding lessons in Scotland? The key for us is that teacher confidence is key to fun, engaging and enjoyable sessions that promote good learning and deeper understanding. And we do mean fun for all of you as well as the kids. It can be daunting to teach something you don't feel you know too much about. But in Scotland, teachers often experience this, and there are a few strategies that we have heard about that have really helped and might be interesting. So the first strategy is around learning communities. And Harvard defined a learning community as a space and a structure for people to align around a shared goal. Effective communities are both aspirational and practical. They connect people, organizations, and systems that are eager to learn and work across boundaries, all the while holding members accountable to a common agenda, metrics, and outcomes. These communities enable participants to share results and learn from each other, thereby improving their ability to achieve rapid yet significant progress. So in Scotland, the shared support that comes from developing a learning community around digital and coding has been key in developing individual confidence. Learning communities have worked through the curriculum, create shared curriculum plans for a year, divided up the creation of resources and lessons, and then shared them across numerous schools. Each time there is someone who understands the topic and can offer advice and support, and someone who's tried the lesson in a class environment and can pass on the tips and tricks needed to implement it. So the second area is pupil voice. And this is how we describe the process of encouraging the children and pupil participation in developing a culture in schools where all children and young people have a voice and have the opportunity to play an active role in decisions that affect their learning and well-being. And this can be done in lots of ways, such as during and as part of teaching and learning. Processes such as circle time, focus groups, and consultations with the pupils. Participatory groups such as the school council, eco committee, healthy schools, and peer mentors, and having structures in place so that all pupils can be involved in decision making. And when thinking about STEM and coding, this could mean talking to young people about what they want to learn and what they want to know. The process can be two-way, so young people can be encouraged to research their ideas and think about how it can be implemented, bringing proposals back to the school. So the final strand, learning together. So this also contributes to building confidence. So learning together, as adults and teachers, it can feel important or even necessary to know more than the students. However, learning together can be a very valuable way of approaching a new topic or new activity. This is about to become even more important as we all try and recover from this COVID pandemic and global experience that we've all been through. So when you think about planning home learning, are you thinking of the parents or carers as co-teachers or co-learners? If we think of other adults as co-learners, what could that bring to the learning experience? With younger children, helping them to understand that adults don't know it all and that adults continue to learn can be a very valuable experience. In older kids, the skills they will develop from suggesting a topic, working with you to plan how it can be taught, and supporting their peers to learning, it provides an opportunity to develop planning, organization, and communication skills, as well as developing the social and emotional skills to support different ways to learning within their class. So, in summary, learning together means not being afraid to learn with your class rather than worrying about always being 20 steps ahead. And I think that's an important thing in life, actually, in general, and certainly something that we've learned as a young company. You have to be open to learning, and it's very can be a transformative way of teaching as well when teachers work with the children in that kind of aspect. So we've also learned the importance of infrastructure, or I should say the importance of how this can affect confidence as well. So when you think of teaching coding and digital, it's easy to think that you need lots of tech, different tech for different lessons and different year groups. And whilst, of course, as an EdTech company, we would purport that some tech is ultimately needed, it doesn't need to be your first step. And I think that's really important for the teaching community. So unplugged is what we call tech learning without tech. So like many areas, Scottish schools often have a lack of computers and laptops or dated equipment, and even sometimes a cupboard full of specialized kit that no one knows how to use. So there's a tremendous amount of learning that can be done without tech, particularly in elementary school. And we certainly encouraged teachers to think about some of this in some of our learning plans with Marty the Robot. So before you even start using the hardware, simple everyday classroom equipment like card, paper, colored pens, pencils can support learning about sorting algorithms, developing a simple program. And as you go up to high school, availability of tech, whilst it does become more important, the key to success is where exactly you invest. So ideally, you want tools that are flexible. Can the investment support maybe more than one class or grade? And can it support learning about more than one topic? Can the investment be adapted as technology changes and learning needs adapt? And also worth considering is sharing. So some regions in Scotland are considering the creation of a technology lending library. And I've heard that this is often used over stateside as well in the US. So where resources are pooled to buy a wide range of tech that is maintained in a central location, potentially a local council or a university, and schools can then borrow it for a term to deliver a set of lessons. A kit is returned and maintained by the central organization, and this alleviates the burden of maintenance of kit from teaching staff and allows a wider range of kit to be bought. So that infrastructure aspect is, of course, important too in developing the confidence in teaching tech and providing an excited community of teachers in this really exciting area. So we noted earlier that there are commonalities between the learning outcomes of the Scottish curriculum and the Georgia Standards of Excellence for Computer Science. So we wanted to now move on to how teachers can support or are supported to plan and structure computer science learning in Scotland. And I hope that this section will just give you maybe something slightly different to think about in the way that lessons are structured. Let's see what you think. So many Scottish teachers break down computer science learning into three broad themes based around what we call organizers. And this is about building a foundational understanding before jumping into coding. But only organizer 3, shown in green, actually involves coding. And this highlights that much of developing an understanding of coding doesn't need you to be an expert programmer. And each part of the Scottish curriculum framework or curriculum map has been aligned to one of these organizers. It's worth noting that this approach to computer science teaching was developed after the curriculum. So it's possible to take an existing framework and view it through these three organizers and consider how you might align the outcomes. So we'll talk a bit more about each of these organizers, and this is what we're going to try and attempt to do, looking specifically at Georgia as well. For your interest, and I'll again maybe be able to write this in the comments once I come off the presentation. You can find out more about this approach to computer science education at www.teachcs.scot. So let's look at the first one. So organizer 1, understanding the world through computational thinking. So theoretical concepts of computing science include the characteristics of information processes, identifying information, classifying and seeing patterns. This strand is about understanding the nature and characteristics of processes and information. These can be taught through unplugged activities, fun, active learning tasks related to computing science topics, but carried out without a computer, and with structured discussions with learners. There's a focus on recognizing computational thinking when it is applied in the real world, such as in school rules, finding the shortest or fastest route between school and home, or the way objects are stored in collections. And learners will be able to identify steps and patterns in a process, for example, seeing repeated steps in a dance or lines of song. In later stages, learners will begin to reason about properties of processors, for example, considering whether tasks could be carried out at the same time, whether the output of a process is predictable, and how to compare the efficiency of two processes. Learners will identify information, classify it, and see patterns. For example, learners might classify and group objects where there's a clear distinction between types or where objects might belong to more than one category. So the second organizer, the understanding and analyzing computing technology. So this curriculum organizer aims to give learners insight into the hidden mechanisms of computers and the programs that run on them. It explores the different kinds of language, graphical and textual, used to represent processes and information. Some of these representations are used by people and others by machines. For example, a set of instructions could be represented as a verbal description, a sequence of blocks in a visual programming language such as Scratch, or as a series of ones and zeros in binary. In this organizer, learners will learn how to read program code before writing it in the next organizer and describe its behaviors in terms of the processes they have learned about in the first organizer, processes that will be carried out by the underlying machinery when the program runs. For example, learners could read a section of code and predict what will happen when it runs, or if lines of code change order. Learners will learn and explore different representations of information and how these are stored and manipulated in a computing system under study. So a programming language defines a computer system. This organizer also covers how other computer systems work, including the components of an individual computer, configurations of networked computers, and software systems such as a search engine. And finally, the third organizer, designing, building, and testing computing solutions. This takes concepts and understanding from the first two organizers and applies them. So learners create solutions, perhaps by designing, building, and testing solutions on a computer, or by writing a computational process down on paper. In doing so, they will learn about modeling process and information from the real world in programs and what makes a good model to represent or solve a particular problem. Learners will create representations of information. For example, learners could make lists, tables, family trees, Venn diagrams, data models to capture key information from the problems they are working on. Learners will use their skills in language to create descriptions of processes that can be used by other people. For example, a computer program is a great way to describe a process. And learners will understand how to read, write, and translate between different representations, such as between English statements, planning representations, and actual computer code. For example, developing skills in writing code could be scaffolded by studying worked examples or by giving learners jumbled lines of code and asking them to put the lines into an order that will give the correct outcome. Although solutions can be created in many different ways, it's expected that all learners will experience creating a variety of solutions on computers. This will show learners that the computer will implement exactly what they have written and not what they intended, as well as giving them practice in debugging. So even with this curriculum framework, and apologies if I was quite lengthy there going into the details, but it can be hard to know where to start. So in Scotland, we took our curriculum map and allocated our outcomes to each organizer. So this helps know where to start because the organizers focus on developing foundational understanding, then progressing to the tools you can use, and then getting to the code writing. So rather than going through a list of curriculum requirements in the order they are written, you can use the organizers to understand how to group the elements of your curriculum map and then what order to teach them in. So the key is nobody needs to cover 100% of outcomes in each organizer before progressing, but you do want to ensure your class have a good grasp of the core ideas within each area. So if I try and bring an example, so this is for grade 5, and we're taking this concept of organizer to your curriculum standards. We've tried to map some of your grade 5 CS curriculum standards to this structure. So we've used the word benchmark to define the statements of what the children need to be able to do within each curriculum statement. So this is organizer 1, but you can see at the top that we are starting with curriculum statements 2 and 5, rather than running them in order from 1 to 5. And this is because it's 2 and 5 that are most aligned to computational thinking. So for those of you very familiar with these standards, you may find that not all the benchmark statements that are defined for the curriculum statements are included. That's intentional. It's okay for a curriculum statement to be aligned to more than one organizer, and then to use different benchmarks within each. So you'll see here the curriculum statement: curate, analyze, and evaluate a variety of resources and digital tools to construct knowledge and produce creative artifacts. And a benchmark: curate information from digital resources using a variety of tools and methods to create collections of artifacts that demonstrate meaningful connections or conclusions. And this could be grouped together in Organizer 1. And again, going through another example for Organizer 2. So we have Curriculum Statement 1. So in following this approach from Scotland, we wouldn't get into thinking about the hardware of technology side of the computer until we had thought about the information, until we had thought about how information was stored and managed. And then finally, in Organizer 3, we can allocate the statements and benchmarks that deal with creating and editing code. And you see these from the Georgia curriculum put into this structure and defined as part of Organizer 3. And hopefully that's just a slight sideways look at how you might wish to organize some of these lessons.
Right, and just having the frameworks now in Georgia over the past couple of years have really identified what we want our students to be engaged with, learn, and be successful with. So that's the frameworks is well done, well thought out.
Awesome. Well, thanks for Jennifer. Jennifer, please just do come in if I'm kind of going off track at all as well relating to Georgia. And so, yeah, in summary, applying the organizer approach, we get a structure to how we apply the curriculum map. And we've gone from a big list of statements to a simplified structure where we build foundational understanding, think about the technology, and only then start coding. So I guess the idea is in using this structure, it can seem quite complicated at first, but the idea is that we really want to simplify it as much as possible for the teachers and allow them to have a structure that is going to really bring learning to life.
Yeah, so I just want to interject because we were actually chatting about it in the chat window. Leela had mentioned that one of her points was getting students to follow detailed instructions, and it is a kind of a flip-flop in the classroom. They want to be creative, and you give them the creative platform, and then they want to have a little bit more structure. So it really is a nice starting point of the computational thinking, and then add on, and then kind of release the students to the task that you want them to do. And hopefully, with your fingers crossed, your students will be open to both concepts from following the directions and then adding that creativity.
Awesome, Joe. Yeah, thank you again. And keep me up to date with the chat box as I can't currently see it. So if people are coming in, I do apologize if I haven't answered a live question, but we will have some time at the end of the session to go through all of that as well. And I'm looking forward to engaging with all of you too. So here we have the setting activities page. So when applying the organizer's structure, it ensures you develop a deep understanding of core concepts in both the class and yourself before you worry about coding. And once we have a broad order to how you want to work through the curriculum, the next thing to think about is the activities that you can use in the classroom. So hopefully this next bit is going to be the fun bit. And using these organizers as a way to structure learning, we can now highlight specific lesson ideas and examples on how you can get your kids started in learning about code. And yeah, we're going to suggest ideas for each of the three organizers split by elementary, middle, and high school. And yeah, some of these ideas are unplugged, which hopefully will be useful. And some ideas will include tech, and we will show a bit about how Marty's been used in the classroom as well, and hopefully that's pretty good fun. So at kindergarten stage, so very young children benefit from playing, of course, and working together to solve problems. And teaching computer science can be a game. So let's split this into the organizers again. So if we're understanding the world through computational thinking, organizer 1, this could be information handling, sorting Lego, size, colors, shapes. This can help them see that there are lots of different ways to sort and organize the same objects. Processes like marble runs and domino runs to understand different steps and changing states. What are the steps to set it up, and what are the ways you can interact with it? How do you how do your interactions change the output or outcome? And in the second organizer, you've got using cards with arrows to learn basic sequencing, build their own version of a robot, use cards to program, in inverted commas, their robot. So one child can be a robot and a small group can be the coders. They lay the cards out and then the robot moves. Can they navigate from one side of the classroom to another? And then learning about tech in everyday life by going on a scavenger hunt. What can they find that they think is a computer of some kind? Automatic doors use sensors. The school bus might have a GPS. Bus stops may have automatic timetables. Their doorbell might have a camera. And finally, in organizer 3, the basic toys such as Ozobot allow kids to see the instructions or colored lines and predict what the bot will do. So using pre-prepared scratch codes, you can make hardware do certain things. So of course, this would include Marty in that. Using pre-prepared blocks, Marty can dance, and that's ideal for kids that can read. And of course, the very successful Bebot has an online emulator as well. So there's not even the need to buy hardware initially at this stage of learning. At elementary school, if we look at organizer 1, you could develop an algorithm to do a dance routine from TikTok, where steps are repeated, kids can learn loops. So we recently did a video with Marty, which hopefully we'll be able to show a bit later on. Maybe you can comment if you want to see it in the chat box, and I'll see if I can bring it up. Sound might be an issue, as we've discovered, but we do have Marty doing the Toozy slides by Drake, and that went a bit viral on TikTok. So kids can have a lot of fun doing that kind of thing, and it really gets the creative juices flowing. But yeah, you can make up a new dance, develop the codes, and the classmates have to do the dance as well and learn conditionals. So if the music stops, you stop. And then in organizer 2, you can spot errors in pre-written code or learn about input and outputs. So you might need an idea for this, and you can develop that learning. And in organizer 3, you might want to use apps like Scratch Junior to try and partially finish programs or edit existing code to see what they can change. You could have a look at our lesson plans on the Robotical website. So the Marty lesson plan, you could check one out, select an example to use, and yeah, again, we'll show you some videos of Marty being demoed with kids as well at the end of this presentation. So middle school, again, organizer 1, learn about parallel tasks through team games and strategies. Try different strategies. What do we learn? Analyze snakes and ladders, tic-tac-toe. Can you predict the course of a game based on the strategy? And learn about sorting algorithms. What is the fastest way to sort your baseball cards or Pokemon cards? In organizer 2, we can look at how computers represent data inside them. And in organizer 3, we could maybe program Marty the Robot to walk around a maze. Or it could be possible to show how Marty can be assembled out of a box as a STEM challenge. Makey kits are also interesting. You can use other materials such as plasticine as well when building bits of hardware.
So most of your students are going to be, not most, but a good many, that the whole idea of creating and making their own, especially as your students move from the building of Legos and move into the understanding of motors, actually putting together a Marty is super engaging and completely hands-on.
Absolutely, and yeah, and you literally get under the skin of the tech, so you're seeing all the different components that have to go into putting a robot together, and that's a really interesting journey in itself. And then finally, with high school, understand the world through computational thinking. So organizer 1, we can deeper understand sequencing and parallel steps, maybe creating production lines in class with origami. Even that can be fun. Can the kids work out the most efficient order to complete steps? Who can make everything without errors, and what steps can be done in parallel? Compare a team doing things step by step versus an individual doing it all. And solve a code or a cipher, use Morse code. Can they define the steps needed to unlock the code? Is letter by letter the fastest approach, or is there a different way? And learn about sorting algorithms by holding races to sort different items, trying different algorithms each time. And in Organizer 2, understand that different information could be represented in exactly the same representation by playing games with binary. Create a black and white picture on a grid, then convert it to binary to show how it could be stored in a computer. Consider the use of databases as a storage concept by trying to build records on topics familiar to the kids, a database of their favorite Spotify songs, thinking about what information is stored about each song. Free services like airtable.com provide easy ways to try out databases. And finally, Organizer 3, create games with multiple elements like timers, points, and player names. And you can do that, of course, with hardware, and that can be particularly good fun. So finally, how can Marty help? I needed to talk a bit about this before the end of the talk. So we've mentioned before that Marty is a relatively low-cost robot, certainly in terms of humanoid robot. It's a low-cost robot that is more than a toy. You know, this is a real learning tool, and it allows kids to understand the progression from using basic Scratch blocks into thinking about real coding languages like Python, and bringing that programming coding out of the screen into the 3D space and into real life and the physical. And with a character, that's a really powerful tool in the classroom. So yeah, you've got build elements, play elements, expand possibilities, and of course, different programs, as mentioned, Scratch, and then real programs like Python. And we're delighted to say that Marty is beginning to get into a number of schools around the USA, and we have had Green Acres Elementary in Georgia. So if anyone is representing Green Acres, I'd be delighted to see your comment in the chat. But yeah, we've got one school in Georgia now using Marty the Robot, over 50 around the US, and that is growing quickly thanks to the work we're doing with Jennifer. And at this point, I was hoping to maybe demonstrate Marty playing soccer. I don't know, it's maybe potentially slightly difficult to do this in this platform, but I'm going to come out of this presentation now, if that's okay, and show you some videos. I think that's probably the best thing to do. Before I go into it, I want to also just point out that with Marty, you do get different stickers allowing kids to design their own Marty. And this is another way to help kids think about emotions and facial expressions. You know, so you can think about social and emotional development. And you can see examples of Marty's very expressive face and how that can be used to support young children to understand emotions. And it's another way to think about creativity. So I just wanted to point that out. But if I just come out of this screen now, let's see. Hopefully you now see me again. Is that the case?
It's we have you, and it's must be spinning on your end, perhaps, because the screen is just grayed out right now.
Okay, that's fine. So I'm going to show you now some videos from Marty, and this hopefully just brings Marty to life a bit. And again, apologies, you may not get sound, but we've tried to create a few videos to just think about some of the things that you can do with Marty. And in this case, we've got Marty the Robot playing soccer. And we've added the scratch blocks above to explain what the kids would need to think about in order to score a goal. Now, I bring this example up in particular because we've done quite a lot of work with a professional soccer club here in Scotland called Hearts and Midlothian Football Club. So Hearts, if any of you are avid followers of the Scottish Premier League. And Hearts have a really interesting digital program that looks to engage members of the community who may be, in an area of Edinburgh that's perhaps a bit more disadvantaged than others. And they've brought along a really cool digital program that featured Marty. So we have done things like have full-on coding soccer tournaments with the kids in that program, where they've used Marty and they've created their own pitches like you saw there. So maybe created different goals and got Marty walking and kicking a ball. But also they've added other bits of hardware. So they've thought about putting in goal line technology. So maybe using a microbit to check that when Marty scores a goal, that the ball has actually crossed the line. They've thought about setting up their own TV stations to film these games. They've even had the Hearts manager come in with the data science expert to talk to them about how data science is used behind the scenes. And in Scotland, you may be aware that one team in particular, I'll say this because I'm a fan, is better than all the others, a team called Glasgow Celtic. And it's very difficult for the other teams to play Celtic because they have a much bigger budget and much more money to attract the best players, etc., etc. And so this data scientist at Hearts spoke about how they use data science to beat Celtic in a cup game, and they looked very specifically at tactics where they would be able to compete. And the kids were really enthralled by that, but it allowed them to think about data science using Marty as well. So how many times is the robot using the right foot, left foot, etc., etc. And that was a really fun way of looking at things. But specifically, in terms of Georgia, we are delighted to say that we are launching a brand new agriculture program, which we know a lot of the school districts in Georgia have spoken about the importance of preparing the next generation for the many jobs that there will be in agriculture, and also agri-tech, and thinking specifically about how farming is changing over the last few decades and how it will continue to change. So working with Jennifer, we're delighted to say we've brought together a bit of a curriculum that talks about Marty's work on the farm. And Jennifer, I've got a few videos. I don't know if I'll maybe just give a bit of a teaser for the kind of work we'll be doing. Is that okay?
Lovely. Oh yeah. So we, Myles and his team, and I work with a lot of teachers and CTEA directors, and they're really looking for that integrated curriculum, cross content, so you can integrate computer science into your STEM, STEAM, and as well as your ELA and your math components. So over in Scotland, they've been very busy taking care of putting together some content and curriculum that will really integrate well with our agricultural needs and focus in Georgia and also the Southeast. Farming's a huge component of our gross national product, what we produce. So this is very clever, and really excited to see some of the beginnings. So you guys are getting a sneak peek into things that are getting designed and implemented as we speak to help really engage students with computer science and where their futures might be. There are things that they choose to go into as they get into the workforce.
Yeah, absolutely. And these are just some videos that kind of hopefully give you an idea in the classroom of how you can really bring Marty to life. So we've got a member of our team has dressed up Marty, got some props together, and hopefully that just shows you how you can create a character that is relevant in whatever you want to focus on. So if it's agriculture, we can do that, but potentially Marty can be someone completely different if you want. But around this curriculum that we've done, we've got a bit of a story that's been created that Marty the Robot, as a 10-year-old robot, has been given a flight ticket to Georgia to spend the summer with his aunt and uncle on the farm. And he's a bit of he's a bit of an indoor kid. He hasn't really been exposed to farm life, and he's got a few misconceptions. So that's the kind of idea behind the curriculum, and hopefully if you are interested, you can email me or Jennifer. We can share a bit more about it with you. But as a bit of a taster, here's lesson 1, and hopefully you can see that.
Got it.
Fantastic. So this is just giving you a bit of background, but initially, of course, it changes when he arrives. But initially, he's not quite sure what he's in for. But as part of being on the farm, he soon realizes that there's a fair bit of coding and programming involved. So with your students, you might want to think about how automation is changing the way that agriculture works, and how robots might be programmed to either do some weeding, do some sowing, etc., etc. And we wanted to bring Marty to life in a cornfield, and this is what Sarah's put together to kind of illustrate lesson 1. But we have a whole lot of activities around counting, as well as creating this code, loops, etc. The kids need to work out what the optimal number of steps, what the optimal speed might be, and there's a whole lot of worksheets that are provided as well alongside that lesson. So hopefully that gives you a bit of a taster. I'll give you lesson 2 as well, just to give you a bit extra. So here students learn how GPS technology programs autonomous tractors, and again, a whole grid can be created. You can think about what a tractor might be doing on a farm using Marty, and programming with Marty, going through certain points within that are on a GPS system within a field. So again, a bit of a taster, and we'd be delighted to tell you a bit more if that was of interest as well. Jennifer, does that kind of help introduce
Yes.
that?
Yes, so it's a very full integrated lesson planned and linear as well. So it lends itself access to a focus. So it's actually a 6-week course pushed into the agriculture business and how agriculture affects all of us throughout the nation, but it's in our standards as far as Georgia focus on agriculture, I believe in 3rd grade. So beautifully put together, lots of fun. I know it's going to be super engaging for the students. I can't wait to get this out and work with some students on it. I think it's going to be kind of a game changer. For the most important thing is to have our students engaged and focused on the possibilities of what future will be. So I think that this really lights some fires. I'm excited to see it with our students. That's
awesome. And yeah, so a whole lot of cross-curricular learning involved with Marty the Robot. I finally wanted to just, again, show you a few dances that some of the kids that we've worked with programs to finish things off and bring Marty further to life. So I think here's a couple from Scotland. You may not be able to hear the sound here, so I do apologize. But in this particular one, can you hear the sound, Jennifer?
No, sound's not coming through, but he definitely has his groove on.
Okay, good stuff. Well, in this one, you might be able to see that the kids have learned about using a green screen as well. And we've got different backdrops. There's a whole lot of schools have done that particular program, which was good fun. And then, of course, you get the costumes as well. So this one, To the Greatest Showman, with features background clapping and applause as well. We really liked this in the office when it came in. And I think it shows how creative some kids can get when they're using a character in the classroom. And finally, the Tuesday slide, which just came in. We really like this because it went viral on TikTok. And again, it's just perfectly synced with music here. If you can imagine Drake rapping, it's it's just really well kind of coordinated. So all that type of thing is great fun to see kids come up with that type of creativity, and long may it continue. So just to finish off, what we're saying, in summary, it's important, learn with your students and share the excitement of developing STEM skills together. Of course, you can use lots of different hardware to do this, but we're today just wanted to flag to you the possibility and the possibilities that Marty the Robot can offer you. This progressive, versatile, and adaptable learning tool for your classroom. And what the Robotical team are really keen to do is to offer a set of activities tailored specifically to Georgia's curriculum standards and support your local industries as well. Because we're a real believer that all of this needs to be joined up for everyone to have maximum benefit.
Yes, just to piggyback on that, Robotical, Myles, and his team have really gone deep dives into studying the Georgia curriculum, the frameworks for computer science, and really want to make a push to make it all in alignment, to make it easier for the teachers. So in addition to the robot, you also have the content curriculum, but I also wanted to kind of show you a winning point for me. This is a game changer. So often, and I don't know, y'all can pipe in the chat, do y'all have problems with your Wi-Fi at schools ever? Because that's usually my running misery. So what we have is a little port, a modem, essentially, that or hub that allows Marty to be on his own network. So all of your devices, your iPad or your Android device would actually connect to Marty's hub. So you no longer have to have the concern of, will I have connectivity in my classroom? It's all here. You plug it in. It has 3 little red dots. When they're all in alignment, your Marty is going to be plugged in with a hotspot that's going to transcend into your device that you're using, and you can just code away with that. Typically, too, just so teachers know, 2 or 3 students per Marty work together and work and facilitate those groups, those group environments that you want. Your differentiation goes there. Leela, I'll have to get with you with the cost, but it comes in a set. Generally, classrooms, you're dealing with 25 to 28 students. So it comes in a set of 10. And I can get you more information on the specs and how that goes. I love it because this was a game changer for me, and there can be so much complication just getting on your Wi-Fi networks within your school due to network configurations and firewalls. So that's an easy give, and also had a ton of fun. So you get a little ball. You get a little ball with your kit, and it really is truly fun to, I could definitely see as a teacher having kind of a competitive, who can get the ball in the other groups goal faster. I always like to throw in a little competition because it keeps everyone a higher level of engagement. but it's been really fun to work off scratch and to make Marty kind of connect with connection points are very important for our students. So to allow him to be able to go into TikTok or be very creative and do those group-like projects, and you can act as a facilitator. It is just lots of fun to work with. Leela, I'll go into, you can send me a private or message that goes directly to me, and I'll help you out and get all the information we need. Are there any more questions? It looks like we have about 3 minutes to help you guys with anything that you're looking to get answered.
Yeah, if there's any more questions, and also, as Jennifer said, we'd be delighted to help give a bit more information. I think my email was just in that address box there. Jennifer, do you mind if I put my email just in the chat?
Oh yeah, please go ahead and add it to the chat.
And that might help everyone. Just
right,
if they did want to speak, and we can copy everyone.
Yes. Perfect. And the participants, if you guys have, sometimes when you're going over things that you want to share with your students and teach, if you have some content or some focus that you want to hone in on with using robotics, Marty in the classroom, and pulling together some cross-curricular information as well, send me an email, because we like to learn. That's what we do. I'm not planning on retiring anytime soon from it. So let us know what y'all are looking for and what your needs are. We'll be happy to help there too.
Absolutely.
And also, I think all the go ahead.
No, go on, Teresa.
I was gonna say all the information will be shared with for all the sessions at the end. So you'll also get information at the end of every at the sessions when we're done. So don't worry about all the information. You should get it, but you can still take it down.
Awesome. Thanks so much. And all you teachers and computer science focus, thanks for what you guys continue to do for our students. And we really want to focus on helping students understand the concepts and go forth and really do great things. Absolutely. So thank you guys for joining.
And I'm delighted once again to be able to come over from Scotland, at least virtually, for the summit. So thank you for having me. And I'll just point out, if you would like a free trial of Marty, we can set that up. And that's something that, absolutely no obligations. We would get the robots to you and your classroom, and you can check out the kit and see what you think before committing to anything further. So that's something that we are offering all attendees at the summit. And we look forward to seeing the interest that comes from that.
And also, thank you too for coming and sharing with us. Great information.
Good, Teresa, it was fantastic. Really proud to be here.
Thank you. Okay, so we've got. Oh, perfect. Feel free to share. Okay. We can. Should we just put that down in the event chat, Jennifer, before we go?
Yeah, let's do.
So I'll just say. Right. That's it there.
I love it. That's perfect. And I'll put my email here as well.
That's perfect, Jennifer. That's great. Well, it's a pleasure, and I look forward to watching some of the other sessions.
Yeah, so yesterday was amazing. So I'm glad that you're able to attend a couple. And you'll learn a good bit. There's so much information out there. But Myles, awesome, just a pleasure as always, and thank you for all your hard work on your end putting this all together too.
It's no problem at all. Great to see you. Take care.
Okay.